Welcome again. So we apply the Cauchy residue theorem to evaluate the integral along a circle of radius 3 centered at the origin. So solution. The first step is to find the poles of the function. So we say here, f of z is a function e raised power zt over z squared into z squared plus 2z plus 2. So poles of f of z are the roots of the denominator equated to 0. Taking the denominator, equating them to 0. i.e., we have z squared into z squared plus 2z plus 2 equals to 0. This tells us that z squared equals to 0 and z squared plus 2z plus 2 equals to 0. Now here z equals to 0 is a pole of order 2. And then this other one here will have z equals to minus b, so minus 2 plus or minus b squared. So our b is 2, so 4ac is 8 divided by 2. So which will give us minus 2 plus or minus, so 4 minus 8 is minus 4. Square root of minus 4 is 2r divided by 2. So z equals to minus 1 plus or minus I are simple poles. So there are 3 poles, 0, -1 plus I, and -1 minus I. So immediately we get the poles, then we have to sketch the given circle to know which of the poles lies within that circle. So here the circle is having radius 3. So okay, this one 3i, 2i, I, 0, -I, -2i, -3i, -1, -2, -3, 1, 2, and then 3. So this is the real axis. This is the imaginary axis. Now the point -1i, so -1i will be at this point, -1 minus I will be at this point, and 0 will be at this point. So all the 3 poles are within the circle of radius 3 units. So all the 3 poles are within C. So we'll be doing calculations for all of them. So for the first one, now residues of the function at z equals to 0, we use the formula 1 over n factorial n minus 1 factorial. So z equals to 0. So residue at z equals to 0 will be given by 1 over n minus 1 factorial, n minus 1 derivative, z minus 0 power n f of z, and this should be done at z equals to 0. I remember our n is 2 because z was a polar for the 2. So this means residue at z equals to 0 will be 1 over 2 minus 1 factorial. And then 2 minus 1 is just 1. So this will be d dz of z minus 0 power 2 times f of z. And you do the calculations at z equals to 0. So 2 minus 1 is 1. 1 factorial is 1. So this means we'll have residue at z equals to 0 will be given by, so this is just 1. So d dz, z minus 0 is just z. So z squared. The function was e raised power zt divided by z squared into z squared plus 2z plus 2. And then remember we do the computations at z equals to 0. So in this case, z squared and z squared cancels out. So residue at z equals to 0 will be d dz e raised power zt divided by z squared plus 2z plus 2. And you remember that the calculations are done at z equals to 0. Now these are quotient of two functions. So we use quotient tool to find the derivative. So let this one to be u, this one to be v. So we need u prime v minus v prime u over v squared. So derivative of e raised power zt with respect to z will be t e raised power zt, then multiplied by z squared plus 2z plus 2 minus derivative of denominator will be 2z plus 2 multiplied by e raised power zt, and then you divide by the square of the denominator. And don't forget that we do this at z equals to 0. So this means residue at z equals to 0 will be, now where this z we put 0, so we'll have t e raised power 0 times t into 0 squared plus 2 times 0 plus 2 minus 2 times 0 plus 2 e raised power 0 times t over 0 squared plus 2 times 0 plus 2 squared. E raised power 0 is 1. So we'll have t into 2 minus 2 times, this will give us 1 divided by, so this will be 2 squared. So that means that residue at z equals to 0 will be 2t minus 2 over 4, which is the same thing as t minus 1 over 2. So that is the residue at the point z equals to 0. Then residue at z equals to 1 plus I will be limit as z approaches 1 plus I of z minus 1 plus I multiplied by f of z. This by definition. So which will be limit as z approaches 1 plus I of now z minus 1 plus I. Our f of z is e raised power z t divided by z squared into z squared plus 2z plus 2. And this we can write it as limit z approaches 1 plus I, z minus 1 plus I times e raised power zt divided by z squared. And because we found the roots of this quadratic to be 1 minus I, 1 plus I, at this point here, these were the roots. Remember, minus 1 plus or minus I. So actually, so this will be negative. So this negative sign here. So this negative, this negative, this negative. So this negative sign here, negative. So will be given by, you can write it as z minus 1 plus I times z plus minus 1 minus I. So just writing this one as a product of two linear terms, which means this bracket and this bracket cancels out. And we get limit as z approaches minus 1 plus I of e raised power zt divided by z squared into z plus minus 1 minus I. Now direct substitution will give us e raised power, so t into minus 1 plus I over minus 1 plus I squared into minus 1 plus I, then just minus 1 minus I. Or we can write this one as e raised power minus t times e raised power ti. Then let's see, the square of this one will be negative 1 squared plus I squared plus twice minus 1 times I. So this is 1, this minus 1 minus 2I. So this is just minus 2I times this one, we have I and I cancels, so this will be minus 2. So which gives us minus minus is plus, and so we have so this is given by, Okay, so -1 plus I, and then this one is -1 minus I, let's see, of course now we have Z -1 plus I, then Z minus Z plus, okay, yes, if Z equals to -1 plus I, and Z equals to -1 minus I, then you'll have Z -1. So taking this one to the left-hand side, so Z plus, then minus I is a factor, and then Z plus 1 plus I. Yeah. So this would be minus, so this would give us, at this point, okay, let me just explain properly from, okay, let me just explain how we find limit. So limit, so next Z is -1 plus I. So residue at Z equals to -1 plus I will be given by limit as Z approaches -1 plus I of Z minus -1 plus I, you multiply by f of Z. So which is the same as limit as Z approaches -1 plus I of Z. Now this will be minus is +1, then minus I, times f of Z is e raised to power ZT divided by Z squared into Z squared plus 2Z plus 2. Now, since we say that the roots of Z squared plus 2Z plus 2 are Z1 equals to -1 plus I, and Z2 -1 minus I, then it means that Z, take this to the left hand side, so we have Z minus Z plus 1 minus I and Z, so take this term to the left, so plus 1 plus I are factors of Z squared plus 2Z plus 2. So i.e. Z squared plus 2Z plus 2 can be written as Z plus 1 minus I times Z plus 1 minus plus 1. So this and this one here are factors of this one. Just like when you are saying, we told that x squared minus 5x plus 6. So this quadratic product is 6, sum is -5, numbers are -2, -3. So x squared minus 2, x minus 3x plus 6 is equals to 0, so equals to 0. then x equals to x minus 2, and then minus 3 into x minus 2 equals to 0. So x minus 3, x minus 2 equals to 0. So x equals to 3 and x equals to 4. X equals to 2 are the roots. So that means that x minus 3 is a factor of this, and also x minus 2 is a factor of this same equation. So that's why when you say z equals to -1 plus I and z equals to -1 minus I, when you take these terms to the left-hand side, take these ones to the left-hand side, so you get this and this one, multiplying the two gives you the original expression. So residue at z equals to -1 plus I will be limit as z approaches -1 plus I. So we have z plus 1 minus I times e raised power zt, and then divided by z squared into z plus 1 minus I times z plus 1 plus I. So with this here and here, this process, so we'll have limit as z approaches -1 plus I e raised power zt over z squared into z plus 1 minus plus I. Now you just substitute directly. So we'll get e raised power -1 plus I times t over -1 plus I squared, -1 plus I plus 1 plus I. And you see this can be written as e raised power minus t, e raised power ti, and this one, -1 plus I squared, is the same as -1 square plus I square plus 2 times -1 times I. This 1 minus 1 minus 2I. So we'll have minus 2I, and then this will be 2I. So which will give us e raised power minus t times e raised power ti. 2 by 2 is 4, and then I times I is I squared, and then times -1, this negative sign. But I squared is -1, so -1 times -1 is just +4. So this will be the residue of that given. So residue is residue at z equals to -1 plus I is given by e raised power. Actually, you can just write it -1 plus I power t divided by 4. Now, residue at the other point z equals to -1 minus I will be limit z approaches -1 minus I, z minus -1 minus I times f of z, so which will be given by limit as z approaches -1 -I, this z plus 1 plus I times e raised power zt divided by z squared plus 2z plus 2. But because z equals to -1 plus I, z equals to -1 minus I, so this implies z plus 1 minus I, z, take this to the left, plus 1 plus I. This and these are factors of this. So we can write limit z approaches -1 minus I, z plus 1 plus I, e raised power zt, z squared into z plus 1 minus I, z plus 1 plus I. So just expressing that quadratic in terms of product of the factors. So this and this cancels out. So we'll have limit as z approaches -1 I of e raised power zt over z squared z plus 1 minus I. So we substitute, we get e raised power -1 I times t over -1 minus I squared -1 I plus 1 minus I. So this will give us, so -1 minus I squared is -1 square minus I square minus or plus 2 times -1 minus I. So this is 1 minus 1 plus 2I. E raised power -1 minus I times t over 2I. And then this and this cancels out. So this will be negative, negative, positive. So this is -2I. So this will get e raised power -1 minus I times t divided by this still before. So sum of residues. So we know by definition integral along C of f of z dz will be 2 pi I times residue at the first value was 0 plus residue of the function at -1 plus I plus residue of the function at -1 minus I. So dividing through by 2 pi I, so 1 over 2 pi I integral along C of f of z dz will be just the sum of the residues at 0, residue of the function at -1 plus I plus residue of the function -1 minus I. So the sum of the residues will be given by, this one was t minus 1 over 2 plus this other one is e raised power -1 plus I times t over 4 plus this other one is e raised power -1 minus I times t divided by 4. So this will give you t minus 1 over 2 plus e raised power minus t over 4 is common to these two terms. So into e raised power it plus e raised power negative it. So this can be written as t minus 1 over 2 plus e raised power minus t over 4. And then this is the same as twice cos of t, which will be the same as t minus 1 over 2, and then plus e raised power minus t over 2, and then cosine of t. So that becomes the solution to that particular problem. I remember at this point here, you could have said this one can be written as e raised power minus t over 2 into e raised power it plus e raised power minus it over 2. And this is the definition of cos of t. Or you can say this is the same as definition of hyperbolic cosine of it, which is the same as cosine of t. So that's how we solve that particular problem.